Today, I'm pleased to share with everyone our team's project. Our project is called Forecast of Hong Kong Housing Rental Information. Next, I will give a detailed introduction to our front-end project. By entering this URL, we will access the main page of the front-end project. The main page features a forecasting module with a carousel in the middle and the forecasting section below. In the forecasting module, we can select the number of samples we want to predict. For instance, if we input 12 and click predict, the system will automatically fetch data from the dataset for forecasting. At this point, the front end automatically scrolls down to the chart area displaying our forecast results. You can see there are a total of 10 columns of data here. Apart from the address and sample prediction columns, the remaining 8 columns are features we selected during our model training. The final prediction results are shown in the last column in sample prediction. It can be observed that most of the data errors are within 10,000, indicating that our model has good predictive performance. Next, I will introduce the visualization section. This part showcases the technical architecture we used in our project, the distribution of second-hand housing in Hong Kong, and some analysis of the second-hand housing rental market based on forecast values. The first one here is the MLP structure diagram, which explains our forecasting method divided into 3 layers: the input layer, the hidden layer, and the output layer. Input layer receives input of A features. Hidden layer 128 to 64 to 32 to 1. Output layer finally output a value. The forward propagation of the network starts from the input layer, goes through the hidden layer processing, and finally reaches the output layer. Back propagation is used to adjust the weight of the network during training. The legend illustrates the network components represented by different colors and shapes. White rectangles represent fully connected layers, light blue represents batch normalization layers, and red represents IELU activation functions. The second one is distribution of second-hand houses in Hong Kong. The location of second-hand houses is marked with yellow dots on the map, and the depths of the color represent the density of the number of houses. From the graph, it can be seen that second-hand houses are mainly concentrated in the central areas of Hong Kong, such as Kowloon, Hong Kong Island, and the New Territories. The number of second-hand houses in Yuen Long and the outlying islands is relatively small. This chart helps to understand the geographical distribution characteristics of the second-hand housing market in Hong Kong, providing reference for tenants. The third one is scatter plot of predicted values vs actual values. Most of the blue dots are close to the red dotted line, especially in the 20,000 and to 60,000 price range, indicating that the model is more accurate in this range. However, in the higher price range, over 60,000, some blue dots can be seen to deviate from the red dotted line, indicating that the model has a certain error in the prediction of higher priced properties, perhaps due to the lack of high-priced housing data or the model's insufficient generalization ability on high-priced housing data. In conclusion, the points in the graph show a positive linear trend, which means that the model is basically able to capture the overall change trend of the house price. The fourth one is histogram of prediction errors. The errors are mainly concentrated around 0, mostly within the range of minus 2000 to 2000, indicating that the model's predictions are relatively accurate. The error distribution is close to a normal distribution with a concentrated center, indicating that the model distribution is generally reliable and has fewer large errors. The error is slightly biased towards negative values, indicating that the model tends to underestimate housing prices. In extreme cases, the model may occasionally have significant errors, but this situation is not common. The fifth one is box plot of prediction errors by price range. The relative error of high-priced properties greater than 30,000 is mainly concentrated within plus or minus 10%, indicating high prediction accuracy. The error distribution of mid-range properties 15K to 30K is relatively concentrated, with fluctuation ranging from minus 10% to plus 20%. The prediction error of low-priced properties equal or less than 15K fluctuates the most, with a relative error range of minus 10% to plus 40%, and there are many outliers. The sixth one is trend of relative error with price. Low-priced rooms less than 20,000, the error fluctuates greatly, and the model tends to overestimate. Medium and high-priced homes greater than 20,000, the error is relatively small and more concentrated, and the forecast is more accurate. The general trend is that with the increase of housing prices, the forecast error gradually decreases and tends to be stable. The seventh one is average absolute error by price range. The chart shows the average absolute error of properties in different price ranges. The data shows that the average error of low-priced properties is the highest, reaching 7.5%, while the error of mid-range properties is the lowest, only 3%. The average error of high-priced properties is comparable to that of medium-priced properties, about 5%. Overall, the model is more accurate in predicting mid to high-priced properties, with larger prediction errors for low-priced properties. The eighth one is heat map of error distribution. The chart shows that the prediction error of low-priced properties is concentrated and small, while the error of high-priced property is dispersed and large, indicating that the model predicts more accurately in low-priced areas and decreases in accuracy in high-priced areas. The ninth one is cumulative error distribution. The chart shows that as the absolute relative error increases, the accumulative ratio rapidly rises and approaches 1 at lower error values, indicating that most prediction errors are small. This means that the predictive model has high accuracy in most cases, but there are also some significant errors. The 10th one is trend of prediction accuracy distribution. The bar chart shows that for nearly 2,000 samples, the relative error of most predictions is 0 to 5%, indicating high accuracy. As the error range increases, the sample size significantly decreases. There are approximately 600 samples receiving the error range of 5 to 10%, and even fewer within the range of 10 to 15%. There are very few samples with an error range of 15 to 20% or more. This indicates that the model is generally accurate, but there may be significant errors in some cases. The 11th one is trend of actual area interval statistics. The bar chart shows that the area range of 300 to 600 square feet has the highest count at 8,078. As the area increases, the quantity will decrease, with the lowest quantity being only one in the range of 3,000 to 3,300 square feet. The chart shows that smaller properties are more common. The 11th one is monthly average sold price and numbers change trend chart. This chart tracks the monthly average selling price (MASP) and the sales volumes from November 2023 to November 2024. The blue line represents MASP and the orange line represents sales volume. MASP remained relatively stable with slight fluctuation, while sales peaked in September 2024 and then sharply declined in October and November. The green and red dashed lines mark the beginning and end of the delta cycle. In summary, despite fluctuations in sales volume, MASP remains stable. At this point, the introduction of the visualization module is complete. The above is all the content of our frontend. Thanks.